Hello, everybody. Today you're going to continue thinking about your multiplication strategies that you're proficient in and apply it to a word problem. So we're just going to take a look at a couple of different examples of some multiplication situations for word problems. So some context that would allow us to solve a problem that regards or that involves multiplication. So remember, multiplication has to do with either equal groups or the area of something. So those are the two kind of most common situations, and rows and columns, I guess, would be a third one. Okay, so we have sort of one of each here. So the most common is thinking of each equal groups, right? So many kids get a certain number of items, and there's this many kids. How many total items? So here's the first example. Tegan brought in pencils for his class. We don't say how many. There are 9 students in his class, and each student got 3 pencils. How many pencils did Tegan bring in? Well, if you have 9 students and each of them got 3 pencils, we're going to solve 9 times 3 to find out the total number of pencils that Tegan brought in. And you're going to go ahead and solve that in whatever way that you do best. Whether it's drawing out those equal groups, is it skip counting, is it using distributive property? I know some of you might say, well, I already know this fact, it's a known fact. Prove it, show how you know, even if you do already know it. So you can draw your equal groups. I might just say, well, I know 9 times 2 is 18. And so if I add one more 9, I'm going to get my 27. Okay? And then you're going to write your statement. Tegan brought in 27 pencils. Remembering your capitals and your periods. So that's the pretty common one. You know, you brought in so many, there are 10 kids at a birthday party and each kid got 2 cupcakes. How many cupcakes did they get? Those types of questions. Here's another type of question that has to do with sort of rows and columns. Mrs. Casano planted a garden. She planted 7 rows of carrots with 8 carrots in each row. How many carrots did she plant? All right, so in this case, we've got 7 rows with 8 in each row, so our problem is going to be 7 times 8. Some of you may want to draw an array, and I forgot to review that in the other video, but an array is also a way of solving a multiplication problem, though once again, not very efficient, but it works. And in this case, this would be a good visual. So I would make my 7 rows of 8 carrots in each row. So 3, 4, 5, 6, 7, 8, and I'm going to take a shortcut, guys, so that you don't have to watch me. Copy, paste. So there's 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, and 7 rows. Excuse me, I'm going to sneeze. So you can see this isn't very efficient, right? But we do have a beautiful array that's set up, and you could singly count those. Again, you can do some skip counting. I would love to see you guys using some distributive property, maybe saying, well, 7 is made up of a 5 and a 2. So if I do 5 times 8 plus 2 times 8, and I know 5 times 8 is 40. We did that in the other example, well, the last lesson. And 2 times 8 is 16. And so therefore we know that the total number of carrots that she planted is 56. And we'd write our statement. Okay, so sometimes we have context where we're thinking about how many in each row and how many rows and how many total. The last context is talking about area. Remember, area is the amount of space sort of inside a shape, okay? And we only talked about rectangles. So if you sort of think about a rectangle, and remember a square is a rectangle, we talked about how this is similar to an array. So if I actually look back up here, right? This is basically, whoops, like your rectangle, right? And we've said, okay, there's 7 this side and 8 this side. And if we multiply those, we know how many on the inside, right? So now we're doing that without having to draw all those X's. So in this case, it says Mrs. Davis built a fence for her yard so Finn could play. He's a runner, guys. Finn can't go outside off leash. So I built a fence. Not true, but I wish I could. Her fence was 9 feet long and 9 feet wide. So I know this side is 9 feet. Whoops. And I know this side is 9 feet. And it says, what is the area of the fenced-in yard that Finn can play in? So once I've built this fencing, I'm asking how much space does Finn have inside to be able to run around without me worrying that he's going to run off? So I can multiply 9 times 9. That's how I'm going to solve it. Now, once again, you could make an array, but that is not very efficient. I would hope that you use a nice strategy. Maybe you have some known facts here. Maybe you know that 9 trick, and you can show the 9 trick off. However you want to solve, you're going to solve and show your work. So this is not enough. You've got to show me how you know. When you do something, a word problem that involves area, it's a good idea to show an area model and to label those sides. One quick reminder, when we're talking about area, the unit is in square units. So in this case, he doesn't have 81 feet of yard because that's just a length. He has 81 square feet of fenced-in yard where he can now run around and play without me worrying about him running off. Okay, so if you choose to do a context with area, you should be sure that your unit is appropriate, that it is square feet, square centimeters, square yards, square inches, whatever unit. Fourth graders, all of these examples were single digit times single digit numbers. I would expect you to write a word problem that would have at least a 2-digit by 1-digit problem, if not something larger. So think about contexts that would be appropriate. Okay, I would not make a yard for Finn because I just don't have the space for it. That would be something like 250 feet by 6 feet. And that would be silly anyway, right? If he has a yard that's only 6 feet wide, that doesn't make sense. But maybe I live on a farm and I'm creating a pasture for some horses. That could make more sense with some larger numbers, right? So just think about appropriate context for your word problems. Think about, does this make sense? Is this realistic? And then write your word problem and go ahead and solve. You can also choose one of the pre-made word problems and put in your own numbers. Again, just make sure it makes sense. It's realistic. Good luck. Have fun. Let me know.